So with this video and talking about market structures and whatnot, I'm going to talk about something we call the shutdown point. And really the shutdown point is just one aspect of this. Really what we're doing throughout this is we're looking at within our different market structures, specifically with this, within like pure competition, how do businesses make decisions about if they're going to continue to produce or if new businesses will join the industry or if businesses will leave the industry based on the profits that others are making. And so that's what I want to take a look at with this. Now, just kind of a disclaimer, I had mentioned this in class, but this information is in a little chart that's at the bottom of your formulas page within your class guide. Now, my biggest concern is that you guys understand that chart, at least that you can, tell me what's going on with that chart. I like to go through these graphs because, as I've mentioned plenty of times before, I'm one of the why people. I want you to be able to understand the why behind things. I'm not going to require that you draw any of these on a test or anything like that, but I want you to at least know the why behind what's going on. So what I want to do first is just kind of show you what these graphs might look like. Because what we're going to do is we're going to graph a few of those numbers that we had on that big production functions chart. That big one with all the different numbers and the different formulas. We're going to graph a couple of those. We're actually just going to graph 4 of them. And the first one we're going to graph is our marginal cost curve. Now, if you notice that initially we start to see our marginal cost decreasing, but then as we start to see these, diminishing returns and negative returns, we see that it'll start trending upward. So it starts going down and then it starts coming back up. Now, if you remember from last unit, we also said that our marginal cost curve is equal to our supply curve. Really, we just kind of like cut it off right here. And once we see this upward sloping part, that's what we consider to be our supply curve because it deals with the cost and increasing marginal costs. We've talked about that all before. And we also have our marginal revenue curve, and our marginal revenue curve here is a straight line, and the reason it's a straight line is because, as we've talked about before, in our instances, our marginal revenue is equal to our average revenue, meaning that we have a selling price that we're keeping the same no matter what the quantity. So this quantity, this quantity, this quantity, this quantity, all these different quantities, the amount of revenue we're bringing in per product is staying the same because we're selling it for the same price every time. We also have our average total cost curve, which again, it slopes downward and then it comes back up. And again, this has to do with those diminishing returns. And then we see our average variable cost. Our average variable cost, if you remember, is if we said our average fixed cost plus our average variable equals average total. So it's average variable is just an element of our average total. Our average variable cost is that cost that's changing time and time again. While our average fixed cost, you'd actually see it would kind of slope down like this and come close to touching like asymptote type toward our x-axis, but we're not going to graph that. So these are the 4 different lines that we're going to go ahead and take a look at. Now, one thing I want us to keep in mind as we see this is that this right here from 0 up to our marginal revenue, this always represents the price of our good up to our marginal revenue. And again, because that's the selling price. That's the price on the ticket for the item. And then we have this right here, from here to this dotted line represents total product. Now, why did this dotted line? Well, if we go up, this dotted line is actually where our marginal cost curve intersects with our marginal revenue curve. And if you remember from our production functions, we said that a company will always maximize its profit wherever our marginal revenue equals our marginal cost. Because once we go past here, at any quantity beyond this, our cost is actually exceeding our revenue, which means it's costing us more to make one more product than we're going to be able to sell it for. We might be able to sell it for $2, but it's costing us $2.50 to make. Well, that's a really bad idea. So we would stop right here, and this is where we maximize our profit at whatever quantity this is right here that we intersect our marginal revenue and marginal cost curves. Now, with these curves, I want to go ahead and talk about some different scenarios about how businesses would react within, like I said, specifically within perfect competition, pure competition as we would see it. Our first instance is wherever our price is greater than our average total cost. And so what we would see is that at that point that we're going to produce, wherever these intersect, what we find is that at this point where they intersect and this quantity, we see that our revenue, so the price that we're selling it for, is greater than the average total cost. And so what that could look like, it might be that right here we're selling it for $2 and our average total cost is $1.50. Okay, so what that means is it's costing us on average $1.50 to make each product, but we're selling each one for $2. So therefore we're making 50 cents off of each product that we sell. Now, if you guys remember, like I had talked before, we had said that this right here represents our entire price of our product. And so if our cost is $1.50 right up to this point, but we're selling it for $2, that means that right here, this extra 50 cents that we're making times the quantity, remember this is our quantity, the 50 cents extra we're making per product times the amount of them that we're selling, that all represents our profit. Now, whatever happens whenever our profits are greater than zero, and our profits are greater than zero whenever our price is greater than our average total cost, whenever that happens and our profits are greater than zero, other companies, other firms might see that, and they say, hey, there is profit to be made within that industry, whatever it might be, there's profits to be made. And so we'll actually start to see more businesses start to enter into that market or enter into that industry. And so if there's profits to be made, business will enter. Now, as we talked about in Unit 2, we know that whenever more businesses enter, that means there's more sellers. If there's more sellers, that's going to shift our supply curve to the right. And what is that going to do to our equilibrium? Well, what it's actually going to do is it's going to lower our equilibrium price. And so if we had drawn like our normal supply and demand curve and we saw that our supply was increasing because an increase in the number of sellers, what we'd actually see is our marginal revenue drop. And so what would happen in that case? What would happen if our marginal revenue did drop, say, to this point right here? If our marginal revenue dropped to a point wherever that marginal revenue, that price, was equal to our average total cost, what we'd find actually is that our profits are zero. And the reason is that if we take the price of the good, which is, again, marginal revenue to zero here, whatever it might be, times our total product, that'll give us our revenue, because we're saying, okay, we're selling each one for $1.50, we're selling 100 of them, therefore this entire thing right here represents that $150 that's going into our cash register. But another thing that we have to keep in mind too is that this, if they intersect right here, all together, price is equal to average total cost. If they intersect all together right here, what we're also saying is that on average, not only are we selling each one for $1.50, but each one's costing us $1.50 to make. So if we sell each one for $1.50 and we bring in $150, but each one costs us $1.50 to make, to produce, and we have to make 100 of them, that's $150 in costs. And if our revenue is equal to our cost, we don't have any extra money that we're making as profit. And therefore, when our profits equal zero, are we going to have businesses enter into the market? Well, no, we're not, because there's no profits to be made anywhere in the market. Also, we're not going to see anyone really exit from the market, because this is economic cost, which we won't worry about right now, but we won't see anyone exit from the market in this case. And so this is actually a break-even point. Right here, wherever our price equals average total cost, we're breaking even. We're saying, okay, our costs are equal to our revenue. There's no profit. We're not losing. We're just breaking even. Another situation that could happen, and this is probably a little more kind of one of the weird ones, is if we see that our price or our marginal revenue intersecting with our marginal cost they intersect together at a quantity, and then that falls between our average total cost and our average variable cost. What we'll actually see then is that we will have negative profits. So we actually won't have profits, we'll have losses. And so here's what that looks like. We have our marginal revenue curve right across here. And again, at whatever quantity this is, we see that our average total cost is actually higher, but our average variable cost is lower. And so what does that look like? Well, what we actually see is that, again, this whole box would represent our costs. Now, why would that represent our costs? Again, this represents the amount of the product we're making, because we maximize our profit right here at this point, where these two lines intersect. So we're making this quantity, and each one is costing us this amount of dollars. So maybe this price right here is $1.25. We're selling each one for $1.25, but on average, each one's costing us $1.50 to make. Well, that means if we look at this, we're making 100 products and we're selling them for $1.25 a piece. That's $125 in revenue. But we just said that we have $150 in costs. So what that leaves us then is with $25 in loss, and $25 in loss, in that we have negative profits. Like, we're not making money, we're actually losing money. And so if there's businesses that are losing money, what we'd actually see is that within the industry, there would be some businesses that would exit the market. Now, if we're looking at this individual, this whole thing as a whole, this individual business, we would say that this business would actually keep producing in the short run. And you might say, Mr. Bradley, why would that be? Why would they keep making their product if they're losing money? That doesn't make any sense. Well, here's why they would keep making their money. Now, a few things I want us to remember. I want to run through a few quick things. Remember, we said that our total product equals our average fixed cost right here. So our average fixed cost times our total product. Now, this is our average fixed cost because remember we said average total cost is equal to average variable plus average fixed. And so if our average variable is up to the purple line, then we know whatever's left up to the blue line has to be our average fixed cost. So we know this represents our average fixed cost, this kind of difference right here. This right here represents our average variable cost. And if we multiply that by our total product, we get total fixed, total variable. So this whole box right here would represent our total fixed cost. This whole box right here would equal our total variable cost. And when we add them together, that whole thing equals our total costs. And so we see this big box right here, our average total times our total product would all be our costs. Now, we have a loss right there of that yellow box, but what we're actually finding is that we're covering part of our fixed costs. Remember, fixed costs are those costs that we're paying no matter what. We have to pay those fixed costs no matter what, and we're at least covering some of it. We might not be covering all of it, but if we just stop producing, we would still have to pay those fixed costs. And we'd actually have more loss that we'd incur if we stopped producing altogether. We would actually lose that much versus only this much. And so we would rather lose this small box than rather lose the big box. And so even though we are incurring some loss right now, our loss would be even bigger if we just stopped producing altogether because we'd still have to pay those fixed costs. So we'd continue to produce in what we call that short run period of time. Now, what we do find is that there is a point we'll get to where we'll say, okay, we're actually better off not producing. Like, we're better off just like paying for the factory, paying our rent, and we're better off doing that than continuing to produce. And when would that happen? Well, that actually happens as soon as we find that our price is lower than our average variable cost at whatever quantity that our marginal cost intersects with our marginal revenue. So let's say that our marginal revenue is all the way down here, and we see that right here where these two intersect, it's actually at a point, at a quantity that the price here, this dollar amount, will fall below our average variable cost and our average total cost. And so whenever we see that happens, what we find again is that our profits are going to be less than zero. And so we see that this entire box represents our costs. That little red box down low represents our revenue. And so what we see is that we have profits that are less than zero, and this loss right here represents our losses from fixed costs. Those are the losses that we would lose no matter what. But what we actually find is that by producing, if we were actually to produce, we would actually end up losing more, which is kind of backwards to think. We would be better off not producing and just losing out on this top yellow box than doing some production and losing out on a bigger box right here. And so what we would find is that in this time frame, we'd actually see that we are better off shutting down. We say this is our shutdown point. Our shutdown point is whenever we would intersect at a point below our average variable cost. We are better off shutting down in that case. And we'd actually see, again, firms would exit the market. The same thing as we saw whenever our price falls between our average total and average variable costs. But what we'd find then, again, with all of this is that if there are losses that are being incurred and firms leave the market, that means the number of sellers is decreasing. Our supply curve is going to shift back to the left. As our supply curve shifts back to the left, we'd see our equilibrium, that equilibrium point slide up along our demand curve. At its new point, we'd actually see that the price rises. As that price rises, it moves us back up toward that point where there are no profits. We didn't really talk about this in class, but just one thing for you to know, within pure competition, we actually see that the what we call, I guess, the market equilibrium is that there are no profits made by anyone, because whenever that happens, there's no entry or exit from the market. We're just kind of at this status quo. So again, like I said, don't worry about having to draw any of these. I'm not going to make you draw any of them, but I just wanted to at least give you the why. If you were kind of maybe struggling to understand that little chart, hopefully you could watch this and get a little bit of understanding of what's going on.